I believe everyone in this room has, at a point in time, operated a mobile or a web app at one time or the other. So once you just click on a button or you send a text message on your WhatsApp, you just see that the person you are texting gets the message and replies almost instantly. But then all these things are happening. So the main reason why this is very important is because by the time you know all these basic things, you'll be able to build to write codes that are actually easy to debug, because the moment you start writing codes that clean codes, you'll be able to debug, because the whole reason why you'll be able to debug is if your codes are clean, you'll be able to know where exactly the issue is coming from and where exactly you have to go to be able to debug what exactly is happening at that place. Because if you start writing scattered codes, you would not even know where the issue is. You just keep parabolating, probably debugging a whole large code base without knowing exactly where the issue is. So the moment you know all these basic concepts, you'll be able to write clean codes, you'll be able to build faster, you'll be able to build a better app with a good UI user experience, because you've used some certain app, the user experience is really, really bad. You can't even relate to how you're going to operate the app. So that's exactly why I think I need to take this session. So how app thinks is basically what I'm going to explain right now. So in the real sense, once you click on a button or you do anything on a app, you would see that it's going to respond automatically. I said there are some abstract functions that are happening behind the scene. Those abstract functions are the code that are being written behind the scene. So you see that once you send a text message, it sends. It's not happening because you just sent a text message. There's already some certain codes that are written behind the scene that made this text message you sent deliver to the person you are sending it to. And in the real sense, you notice that you can actually do 2-3 things on a certain app at the same time. The only reason why that is possible is because the app is asynchronous. Asynchronous is the ability of a app to perform multiple tasks at the same time. So the only reason why you're able to do that is because the most apps, like almost all apps should be asynchronous. And there's something called your event loop. The event loop is just basically what checks if there's a pending task that needs to be executed. So the event loop is just, it checks, is there something that needs to be done? If there's something that needs to be done, it would execute it. So what's the event loop? Do you know what a to-do list is? To-do list is just like your mini Google Calendar that you can add those things you want to do on a daily basis to. So that's exactly, I'm just likening it to what an event loop is. So an event loop contains the list of tasks the apps needs to perform. So it keeps checking, is there any task I need to perform? Has this person done this? Has this person clicked this button? Has this person sent this particular message? Has this person done this thing? That's exactly what the event loop is looking at. So it's to just check if something is ready to be executed or something is awaiting execution, and it automatically does it. Okay, so I was explaining the event loop. This is the slide. Excuse me. So it's just check if there's something to do. If there's something to do, it moves it into the event queue. And if there's nothing to do at that particular point in time, it keeps checking, is there something it needs to do? Is there something it needs to do? So if it gets something it needs to do, it will obviously move it into the event queue. Okay. Okay, so moving on, we have something called a call stack. So a call stack is just basically where your application is being executed. So it is where your application that is running, whatever is running currently at that particular moment, that's where it runs. So the event queue is where tasks wait for their turn. Like I said earlier, there's something called asynchronous task. And for asynchronous, we make use of the async and await. I don't know, developers do, you should know what async and await is. So it enables asynchronous property of a particular function. So it is inside that event queue that lineups of tasks would be. There are features on LinkedIn and Telegram where you can schedule messages. So to schedule messages, by the time you schedule a message, it's a task that is already in place to be executed. But because it's not yet its time to get executed, it has to wait for its time to get executed. So it waits inside the event queue. Then the event loop is what moves tasks from the queue when the call stack is empty. Like I said earlier, the call stack is where the codes are being executed. So at every point in time, once a particular code has been executed, it will obviously be free. So once it's free, the events loop will just move the particular task that needs to be executed at that point in time. So it moves it into the priority task. Let me call that. So the priority task, you know what priority means? The most pressing task that needs to be executed. So it moves it into this call stack because it's already free at that point in time. So the event loop will continue doing that because once it sees that the call stack is free, it moves whatever needs to be executed into it. So it does what it keeps doing at every point in time. So it's the events loop, like I said earlier, is an endless to-do list that keeps having one thing or the other to do. The slides is all moving. I don't know why, but doing this case without explaining an API. An API is an acronym, so it means an application programming interface. So you know what an API is? An API is just, locations on Google Map. Igom, yeah, on Google Map, I'll just send a request to Google Map that, okay, get me all existing restaurants around this axis. And this is going to like get me the response. It's majorly because Google Map is free to use, and that's why you're able to access it. As a developer, if you want to make use of Google Map in your application, it's not free, it's paid because you want to make use of it in your application. Although there are free trials, there are certain requests, number of requests you can make without paying on your Google Cloud. And I think Google Cloud gives some certain credits that you can use if you're working on a low scale. So the only reason why you're able to make use of Google Map API at that point is because the API is public, is external, where you can have access to it. Developers will know what bcrypt is. Bcrypt is just something used in hashing password. You can use it to verify password, you can use it to compare password and the likes. The only reason why you're able to hash your passwords and able to call those functions inside bcrypt is because those functions are public, they're accessible to you. Bcrypt is free, but you can make use of all those functions in it because they are accessible to you. So in the real sense, bcrypt itself is a library, but it has external APIs that are free that you can make use of at every point in time. So like that's a brief overview of what an API is like. So when you're making use of API, you send a request, you make a request, and by making request, it's like you are sending a letter to someone. So you're telling this, okay, get me the locations around this axis. So by the time it gets the request, by the time the server gets the request, it processes it. So by the time it gets all the information, all the restaurants around this axis, it's going to give you the response back. And that's when it displays on your UI. So in the real sense, you're able to do all those things because you have access to those APIs. So the next slide is just an API example. In the real sense, the main reason why we have external APIs are just because you can't expect me to start writing. Okay, it's like you wanting to get locations around a particular geographical area. Then you now decide to start building Google Maps from scratch. It's so illogical because the amount of effort and time Google puts into building that thing, I don't think you can get that within a small time frame. So that is the whole idea behind using external APIs. So in this case, we'll be making use of an external weather API. So you want to get a particular weather from this API. So once it gets the response, it's going to save it it's getting it in like a JSON format because response from APIs comes in JSON format. And JSON is also an acronym, JavaScript Object Notation. That's like the full meaning of JSON. Is also an acronym. A lot of people see it as a normal word, but it's an acronym in the real sense. And then we are logging the response from the API. So it's just going to get a JSON, probably the name of the location, the temperature, and some other information that is accessible within the API. So, like I had said earlier, this is just an analogy of a response to message and get request. So you are telling us, okay, get me the weather of, let me use Costain for example. Get me the weather of Costain. It's obviously going to guess. Most weather APIs gives you that day, the following day, and it gives you like 3 days. So it's going to give you the response because you sent a request. Get me the weather of this particular location at this particular time. And once the server processes it, it's going to give you a response. So it gave city, London, and temperature in London. This is not real, but then 22 degrees Celsius. So this is just the weather, the degrees Celsius of the weather in London. And JSON is a language. The main reason why JSON is very easy is because it's a language the machine can process, and it is a language human beings can understand. That's why most times API responses comes in JSON format. So, application that will not be slow and will not freeze, because if the app waits at every point in time you send a request, you send like 3 different requests, and it is waiting for it to process the first request before processing the second request, before processing the third request. Number one, user will get really, really tired and will like be like, what kind of application is this? So that's the main reason why you have to make use of asynchronous code in getting response. So it's just going to implement the most pressing one. So it's going to be processing every other thing, and once the response for a particular one comes, it displays it to the UI while it is still processing the rest. So the rest are being processed in the background. You can't see it obviously. So the rest are still being processed in the background. But anyone that gets the response first, then it displays to the UI. Real-time updates, apps like COD and the likes, it cannot wait for a request to, because the number of things you are doing at a particular time, you are killing someone, you are shooting, it has to like reload your gun once your bullet is like exhausted, all those things. There are a lot of processes that is being covered within like very short time frame. So apps like that needs real-time updates. Once you kill someone, it should reflect in your score. Once you do anything, it should reflect automatically. That's the beauty of most of those apps. That's why a lot of people enjoy using them. There are some apps way back in probably 3-4 years ago, people no longer play them because they were not able to move with the trend. But you see that COD brings new crazy updates almost every time because they need to move on with the trend. And if they also deal with app that does not give you time updates, it will be so shitty in the sense that the moment you shoot, it will still wait for a few seconds before once you kill someone, it will wait for seconds or minutes before it reflects your score. And the beauty is just that you know that I'm already ahead of you, Motila, something like that. I'm already ahead of you, Alpha, get out, things like that. So that's like the beauty of most of those apps. So they need real-time updates to stay connected with people that are playing it. So not like they'll be sending requests at every point in time. You get like shoot someone, then it's a wait to process that request before giving me that, okay, I already killed the person. So it's like it's always giving you time updates. Shoots the person, it updates your score. Once your bullet is exhausted, it immediately take time to like reload and do all those stuff. Okay. Point in time, you are waiting for the thing is, most times in the stock market, the moment stocks start falling, you are getting updates, your money on lolly. If the those their products are booming, your money is increasing almost immediately. So you know that, okay, I need to come on my money like almost immediately, because at some point you can put $500, wake up the next day, what's the law, you see 100 and something dollars there, and like you are good as the money you are planning, okay, in the next few months or so, Mafishe, that's December. What's it so in the real sense, apps like that needs almost immediately like real-time updates, so that once my money is going down, or once I check Twitter and I see that they are roasting this particular company or they are doing this kind of thing, because all those things influence company stock prices, you know that this thing is going to affect the stock of this company, let me quickly move my money. So following real-time updates like has effect on a lot of applications, because that's the only way we as a user and they as a company will be able to benefit, because obviously bamboo that we use benefits from us, and we that are using it we benefits too if company stock price increases. So the only way we'll be able to enjoy using their app is if they give, because bamboo serves as a section where it gives real-time updates that this company, there's a tendency that it skyrockets, or there's a tendency that even with the fact that they gained so $1 billion investments, they would still not be able to meet a particular quota or something. So you quickly know when to remove your money and when to do your stuff. So I'm just going to explain what polling, there are concepts in real time, like I explained earlier, stock market and apps like COD. These are some of the concepts they use while building the application. So I'm just going to explain what this concept means. We have polling, we have long polling, we have WebSockets, and we have server sent events. Server sent events is like a whole huge concepts on its own, so I'm not really going to dive into that. I'm going to explain what pulling, long pulling, and WebSockets is. Pulling sends requests to the server almost immediately. It sends requests frequently. It asks it, okay, alpha, all the time. Like, asks it, alpha, is there any updates? Alpha, is there any updates? Like, almost immediately, just to check if there's any updates. But long polling, it asks just once. It asks the server once, and the server holds the request until something entirely changes that particular connection. That's the only time it's going to release that connection and restart another one. And the WebSockets, it keeps a two-way connection, both, and the API, both of them can communicate at any time. Both sides can communicate. Okay, alpha, is something wrong? Alpha, give me a response, something like that. So that's on the, that's that on that. So this is an example of a WebSocket implementation. So a message from this particular, turn the message and log the message onto the screen. Oh my God. So the events loop just keeps the whole application responsive, because it keeps checking if there's anything that needs to be done at every point in time. And that's the whole idea of asynchronous and synchronous. I already explained what that. Okay, I did not explain synchronous. Synchronous is just when something does just a single thing at a particular time. And if your app start doing just a single thing at a particular time, you won't even enjoy the app. So that's the whole idea of asynchronous tasks, because it has the ability to do different things at a particular time. Then API calls, it allows you to get requests. It just allows servers at every point in time. So you'll be able to get real-time response from the servers. Then the real-time that I've been mentioning all the time since morning, it just pushes updates instantly. So together, all these three concepts create a modern and interactive application, because that's exactly what most, don't let me say most, all web applications, mobile application time updates at every point in time. So the only reason why I've been talking concepts since morning is just to have an app that is responsive, be able to hold lots of requests and responses at a particular time, because that's the only way everyone is going to enjoy the apps. So without all these things put in place, that the app is unresponsive at a particular time because the requests are too much. You see that in Nigeria, okay, I don't know about other schools, but in LASU, once it's time to check results, the thing will just stop working. Like, if they tell us like just to go on the application to check 9 o'clock, I assure you within 10 minutes, server is going to shut down. Like almost immediately. Once it's 10 minutes, students on the server like this, it goes down, and they'll not be able to wake it up till like the next 24 hours. I don't know what they are doing, but they won't be able to wake it up till probably one wait till only if you can access lecturer portal. So that's what we go through at every point in time, because you want to check your result and you have rights to it. But because of all these issues, you just have to sit down there because there's nothing you can do about it. But by the time all these things are put in place, we would have a better experience with all these apps we are dealing with. So I already explained all of this. So apps don't just run, they listen, they respond, and think. Thank you.